So good morning to everyone. My name is Diana Lee, and I currently serve as the Federal Program Manager for the Microreactor Program in the Office of Nuclear Energy. And today I'll just be giving an overview of the activities within our Microreactor Program and discuss our NEAP call for this year for the microreactors. But before I begin, I also want to acknowledge John Jackson. He is our National Technical Director for our Microreactor Program, and he's a really great resource if anyone has questions about our program. Okay, so within our program, our microreactor program is very much in alignment with the Office of Nuclear Energy's strategic vision, which is to demonstrate a microreactor by 2025. To achieve this vision, we are working through cross-cutting research and development to achieve technological breakthroughs for key features of microreactors. And this will help us reduce risk and the timeline to further enable successful demonstration of multiple domestic commercial microreactors in the future. So to meet this vision, our microreactor program is organized into 3 technical areas. The first is for system integration and analyses. And within this area, we are focused on identifying the needs and the functional requirements and the, excuse me. Oh, I'm sorry. The needs and the functional requirements and the applications of microreactors through economic and market analyses. We're also looking to identify innovative microreactor supporting capabilities, such as computational methods through use of the NEAM's computational tools. And we're also performing regulatory research to really help us build the microreactor regulatory basis to allow microreactors to be licensed. The second technical area that we are focused on is technology maturation. And within this area, we're looking at heat removal capabilities such as heat pipes and heat exchangers, gas cooling, and how these different technologies could couple with power conversion units. And we're also looking at advanced materials such as high temperature moderators like yttrium hydride and grade 91 for components. And we're also working to provide legacy data on fuel for developers and work with our materials programs, our instrumentation and sensors programs to really close all those technical challenges. And the third area that we're focusing on is demonstration support capabilities. And within this area, we are developing several non-nuclear and nuclear test beds, such as our single primary heat extraction and removal emulator, or SPEAR. And this SPEAR will allow us to test various heat pipe designs and address questions that come from the regulator as well as from industry. We are also working on Magnet, which is our microreactor agile non-nuclear experimental test bed. And this is going to allow us to test increasingly larger test articles that would couple heat pipes and heat exchangers again with power conversion units, as well as allow us to couple with things possibly such as a high temperature steam electrolysis skid, because we're going to be implementing Magnet within the Integrated Energy Systems Laboratory. And finally, we are also working on developing MARVEL, which is our microreactor applications research validation and evaluation test bed. What this is a nuclear microreactor that would be installed in the treat in a storage pit and treat, and this would allow us to demonstrate end user capabilities such as high power computing and heating, ventilation, and cooling. And we have a list of different end user capabilities that could be supported by nuclear that's not currently really supported. And microreactor technology could really enter that energy sector. So these 3 technical areas would all help us meet the eventual vision of having microreactor technology provide remote heat and power, hydrogen cogeneration, district heating, desalination, as well as electricity. So with that, our planned activities are stemming from these different focus areas within our program. So in the next few years, we are planning to work on procurement and construction of our Marvel facility. We will be testing an integrated core block and heat exchanger and power conversion system in magnet. We will be testing several different heat pipe designs in sphere, and we will be completing our yttrium hydride post-irradiation examination so that we can provide that data and support use of yttrium hydride as a high temperature moderator. And we also plan to complete supplying our metallic fuel, our legacy metallic fuel data, and qualify that data. And we will be implementing what we learned from our regulatory research plan and closing regulatory gaps, as well as continuing stakeholder engagement and providing access to Sphere, Magnet, and Marvel so that we can all work together to realize our long-term mission to provide microreactor technology. So I guess that brings us to this year's call under RC-2. And our focus for this year is really to hopefully identify ways to reduce or enhance the economic, to enhance the costs of microreactor and look for ways to reduce timelines through enhance microreactor construction capabilities and other areas. So we've listed here some areas that we suggest. It's not all encompassing. We're really looking for input from our primary investigators and the teams that you put together in your proposals. We are really interested in what you have to say. So I'm just going to mention some of the areas that we wanted to look at as areas of interest. First is possible microreactor designs with transformative economic reduction potential. And then readily deployable control technologies that would enable unattended operation. We're always open to any input on moderator, reflector, and fuel technologies that might increase efficiency or economy of fuel use. We're looking for possible advanced heat transfer or power conversion technologies and also storage systems. And we're looking for ways that would allow standardization or efficient factory manufacturing of microreactors, which is really one of the key, I guess, functions or unique factors of a microreactor that make it more applicable to remote locations. We're also looking for possible improved ability to support non-electric applications such as process heat and ways to enhance reliability and capacity factors, and also input on minimization of on-site construction, again, for remote applications. And finally, we're also looking for any input on compatibility with local microgrids and the ability to scale loads to really address as demand changes over time. So here I just provided a chart that's also with, should be provided in the full funding opportunity announcement. So I do suggest that anyone who's interested check and read through the actual language in the funding opportunity announcement, because that's always subject to amendments. And so that is really the basis of what we will be looking for through proposals for. So read through all those details and make sure you're looking at the most latest version. But these are just suggested performance targets that we believe if these are met, that a microreactor could be economical and and competitive in the current market. Again, these are suggested, they're not required. It's just here for some guidance. So with that, I guess I can take any questions, and I believe we also have John Jackson on the line.
Thank you, Diana. We have some questions coming in, and I just want to remind everybody here that you are welcome to type your questions into the Q&A feature of the GoToWebinar, and we will ask them to Diana and John. The first question is, will the instrumentation and sensors development include consideration of proposals for instrumentation and sensor systems, including innovative neutron sensor development for reactor power monitoring?
So I think we want to leave it to see the details in the proposal. From that short description, it sounds promising. Of course, we definitely want to know what is occurring in a microreactor, especially if we're going further down the line and have microreactors in remote locations. But John, I defer to you for further input.
Yeah, I agree, Diana. That sounds promising based on the question. What I would advise, though, is to make a strong case for viability improvement of microreactors. So tie it to utilization for autonomous control or health monitoring or something to that effect. So in other words, just developing neutron sensors in a vacuum is not acceptable. We want to make sure we clearly tie it to the microreactor viability improvement philosophy.
We do have a couple more questions. The next question is whether this is part of the CINR FOA and how much funding is estimated for this area.
Funding is, always up in the air. It won't be finalized until we know what is provided in the next budget. But yes, this is part of the CINR FOA. It's in the scope. It's for 3 years, up to $800,000 for one project, and hopefully we could award more than one, but we will just have to see.
Thank you, Diana. The next question is modeling and simulation of interest? If so, what area and what computational tools are desired or needed?
Yes, modeling and simulation are of interest. Again, we do leave it up to the proposal to give us details on what you are suggesting. We don't want to outline what, and direct you exactly, but I believe the different investigators have a good sense, and you can always talk to me and John for further information on what we are focused on right now. But yeah, I don't want to narrow down the scope right now. I prefer that you detail challenges and gaps that you are aware of within the microreactor industry and detail out your pre-proposal, and then and and there are definitely many experts that you can speak to for input while you're drafting your proposal together and figure out what our different modeling and simulation gaps are and challenges.
Thank
I
you
guess,
again.
John, would you want to say something further?
No, I think you captured it really well. I would say, we are always interested in validation of the NEAMS tools. So, the Moose family. And again, making sure that we're doing something to improve the economic viability of microreactors.
Okay. The next question is RC-2 for university-led, or is industry available to lead a project in RC-2?
RC-2 is meant to be university-led. That doesn't mean you can't collaborate with industry.
Okay, thank you, Diana and John. I don't have any more questions. So on that note, if there aren't any other questions, I think we can resume at 10:30 for the next webinar.
Okay, great. Thank you very much.
Thank you.